Tiffany's house.
So the first order of business is that we only have a single right now. I have no idea why. It's a B day because we're supposed to have a B day on Friday. So I guess they just didn't skip the day. Usually we do skip the day if we have a snow day, but you only have a single. So whatever you have on B days is what you have next period. We're not taking the test. We're going to take the test on Friday. So it's just going to be the same test. I'll review with you again and I'll give you more questions or something. I'll figure it out. But you're just going to have the same test you would have had on Friday. I didn't want to waste today on that. So we're going to do that. So we're just going to do this lesson 44 if you could take that out. And I think you had homework 43. Did I check that yet? Let me check. Maybe I checked it on Friday. I don't remember. Hold on. I usually don't check on Fridays. I checked it. Okay. Oh, yeah, because I didn't do a lesson on Thursday. So no homework that I need to check. Just take out 44. And today we're going to talk about coordinate geometry proofs. Our last lesson was 43, which was basic introduction to proofs. So we talked about how to prove two lines are parallel, how to prove two lines are perpendicular, things like that. Today we're moving on to how to prove different types of triangles. So you need to know the 3 different types of triangles that we learned about. Equilateral triangles have 3 equal sides. Starts out with the word equi, kind of like equal. Isosceles triangles have 2 equal sides. And then a scalene triangle has 0 equal sides. And then we also talked about one other type of triangle, which is a right triangle. Which basically just means that it has 1 right angle. So when you're proving different types of triangles, you're going to use the distance formula to prove that different sides are congruent, because the distance formula tells you the length of different sides. So the first problem says prove whether the following triangles are isosceles, scalene, or equilateral. So the first thing you're going to do is you're going to plot those points A, B, and C. And you're going to connect it like a triangle. So an isosceles triangle has 2 congruent sides, a scalene has 0 congruent sides, and an equilateral has 3 congruent sides. Since they're not asking you about a right triangle here, we're just going to do the distance formula. If they were asking me if it was a right triangle, I would have to do the slope formula because I would have to prove that 2 sides are perpendicular. But when they're just asking about these 3 types, I can get away with just doing the distance formula. So what you're going to do is you're going to set up a table and you're going to label each side. A, B, B, C, and C, D. Not D, C, A. Like this. And you're going to find the distance of each side. So again, you need to know the distance formula. We're going to do tomorrow. I'm going to give you an index card, and you're going to write down all these formulas on that index card so that we can just have them on our desk when we're doing this. And you can have that study for the test because I don't think we know the formulas. So the distance formula, just to remind you again, is the square root of x1 minus x2 minus squared plus y1 minus y2 squared. So you're going to use that to find the distance of these 3 sides. Okay, so the coordinate for A is -2, 1. Coordinate for B is 3, 4. And the coordinate for C is 6, -1. So that's how I like to do it because it's just faster. If you want to go through each time and label the points, you can do that. You're just subtracting A minus B, B minus C, C minus A. And then for each of these, you're going to plug in what's underneath the radical into the calculator. So we'll do the first one together. Parentheses, -2 minus 3 squared plus 1 minus 4 squared. Gives me 34 underneath my radical. So that's the length of side AB. Then you're going to do the same thing with side BC. 3 minus 6 squared plus 4 minus -1 squared. Gives me 34. And then the last one, you're going to do the same thing. -2 minus 6 squared plus 1 minus -1 squared. Which is 68. So what type of triangle is this? Brenna.
Isosceles.
Isosceles, very good, because it has 2 equal sides. So the way you're going to write that is AB is congruent to BC because their lengths are equal. Then you're going to use these 3 dots in a triangle form. Like that. And that means therefore, I think I taught you that last year. I don't remember. Triangle ABC is isosceles. Questions about that first problem? Okay. You can flip to the next page. And they're giving you your 3 points, RST. Since we aren't really using the fact that we graphed it, it's up to you if you want to graph it. Normally on these problems, they make you graph it. They say in the directions you must graph it, which is nice because that's like a free point. But I'm not going to make us graph it right now because we're not really using it. So this is the same question as before. We're proving that it's one of those three: scalene, isosceles, or equilateral. So we're going to set up our table with our sides, RS, ST, and TR. And we're going to find the distances. Okay, so R is -1, 3. S is 1, -3. And T is 4, -2. And then you're going to find each of those distances. So plug those values into your calculator, please. We need another minute. Okay, what do we get for the length of RS? What number goes under the radical? Maddie, what'd you get? Good. What about ST? What number goes underneath the radical? Brenna?
10.
Good. And what about the last one, RT? What number goes underneath the radical? Chris? Good. So none of these sides are equal. So we're going to write that. None of the sides are congruent, or you can say equal, doesn't really matter. So then we're going to say, therefore, triangle RST is scalene. questions about that? Okay. Next thing they can ask is they can ask you to prove that something is a right triangle. Or they'll say, prove whether it's a right triangle. Normally when they are asking you to prove something, they're telling you, prove it's a right triangle. So you already know that it's a right triangle, you're just doing the math to back that up. This is asking it a little bit differently, but on the Regents, that's how they'll say it. So they gave you these points, and you have two different options here of how you can do this, and you can choose whichever way that you like better. You can find the lengths of all three sides and then plug it into the Pythagorean theorem, and then if the equation is equal, it's a right triangle. I think that's a little bit tedious to do, especially because finding the lengths of the sides, I just think the distance formula is annoying. I try to avoid using the distance formula if possible. The second option is to find the slopes of all three of the sides, and if one pair of sides have negative reciprocal slopes, that means they're perpendicular, which means it forms a right angle. So we're going to use the slope method for this problem. And then if you like the other way, I'll show you on number 4, we'll use the other way, okay? So this is what we're going to do here. So we're going to find the slopes. So again, you're setting up your table. Every single problem, you're setting up a table all the time. AB, BC, CA. And we're going to find the slopes now. Slope formula, y2 minus y1 over x2 minus x1. Okay? So when you find the slope of AB, I get 5 minus 1 over 4 minus 1, which is easy. Don't even need to plug it in my calculator or with Rick. BC is going to be 1 minus 5 over 4 minus 4, which is negative 4 over 0, which is undefined. And then CA is going to be 1 minus 1 over 4 minus 1, which is 0 over 3, just 0. Now, this is something that will happen sometimes. They will give you undefined and 0 as your slopes, and you need to know that those are negative reciprocals. We talked about that a little earlier in the year. I don't remember in what context we talked about it, but those are opposite slopes, okay? They're negative reciprocals because 0 is neither positive nor negative, and same with undefined, but you flip the fraction. Here the 0 is on the bottom, here the 0 is on the top, okay? So since those are negative reciprocals, we're going to say BC is perpendicular to CA, since their slopes are negative reciprocals. And then we're going to say, therefore, triangle ABC is a right triangle. Questions on that problem? Okay. You can flip to the next one, and you can set up your table for the next one with your sides, DE, EF, and FD. And now we're going to do this using the distance formula. We're going to prove whether or not it's a right triangle. So we're going to find all three of the distances. So I want you to do that now. find the distances of these three sides. All right, what did we get for DE as the distance? Brenna?
Hold on, equation.
You don't have to give me the equation, just the answer.
Radical 25.
Good. Radical 25, which is the same thing as just 5. So the square root of 25 is 5. What about EF? What do we get for the distance of side EF? Chris? Good. Radical 50. And what about FD? What do we get for the distance of that one? Go ahead, Brenna.
25.
Rad 25, good, which again is just equal to 5. Now, the reason that I don't really like this method as much, aside from having to do the distance formula 3 times, is now after you do all that, you have to now plug it into the Pythagorean theorem. A squared plus b squared equals c squared, which means the two smaller sides are your legs, or your A and your B. So you're gonna say 5 squared, or you can say radical 25 squared if you didn't simplify it, it doesn't really matter, plus 5 squared equals radical 50 squared, and you're checking to see if that works. If that works, it's a right triangle, because every right triangle, the sides fit into the Pythagorean theorem. If that does not work, it's not a right triangle. So 5 squared is 25, plus 5 squared is 25, equals rad 50 squared. Whenever you take a radical and square it, you always just get the number underneath the radical, but if you weren't sure about that, you could just plug it in your calculator, and you get 50. And we all know 25 plus 25 is 50, so 50 equals 50, so that works. So now the explanation you're going to give for that.
The owner of a black Volkswagen Passat, license plate CCU 9850, your lights are on. Please see a security guard to let you out of the building.
Is triangle DEF is a right triangle. because it satisfies the Pythagorean theorem. So it's up to you which one of those methods you prefer. I definitely prefer the slope method because I think it's easier. Questions on number 4? Okay. We come down to number 5, and we're going to do number 5 using the slope method. So we have our sides, RS, ST, and TR, and we're finding the slope of all 3 of those sides. So go ahead and do that. So I like slopes so much better because they're so much faster. So your slopes are 7/1 for RS. ST was 3/4, really -3 over -4, but a negative over a negative is positive. And then TR was -4/3. So you'll notice these two are negative reciprocals of each other. Signs are different, and the fraction's flipped upside down. So you have to say those two sides are perpendicular. And you don't ever have to write out the word perpendicular. You can just use the upside down T symbol. So ST is perpendicular to TR because the slopes are negative reciprocals. Therefore, the triangle is a right triangle. Okay? Questions about that? I know this is a lot. This is the easiest of the proofs that we're going to do because the rest of the week we're going to be doing quadrilateral proofs. So all that stuff is coming back. Rectangles, squares, rhombus, trapezoid, all that fun stuff. So we're starting with triangles. It's a little bit easier, a little bit less work. Okay? So you can put that away and take out your homework packet. I'll tell you which ones you're going to do. I'm not going to give you a lot on this because the questions are really long. So you're going to do number 1 and 3. Okay? And last week, the plan was that your delta math you did was going to count as part of your test. I think I said I was going to do 40% delta math, 60% the test. I'm going to still do that somehow. What probably will happen is I'll just give you a new delta math, and we'll work on it one day this week. But I'm not too sure yet. I have to talk to the other geometry teachers, so that will still did say, because I want this test grade to be a good one because we're coming around to the end of the quarter. Okay, so that's why we're doing that. So maybe what I'll do is, I'll just count that Delta Math from last week as its own quiz, and since like almost all of you got 100 on it, then it should be a grade booster, and then we'll do another Delta Math. That may be what happens. Yeah. Okay, I'll put it in there. Yeah, I see it here on the thing. I just got this stuff.